Hey guys, welcome to lesson 2 where we're going to be having a look at the effective annual rate of interest. Our goal today is to calculate effective annual interest rate, and there is a formula for this and it's quite straightforward. So let's get stuck into it. If we consider a financial institution advertising a rate of 3.5%, this is normally what we call their nominal interest rate. Okay, it's what they're advertising, but it's not really what you get. In reality, the investor doesn't receive 3.5% per year on the money because you have compounding interest. So you actually end up receiving a lot more than that. We saw that in yesterday's example where if we just had, it compounding annually, we ended up with $5,300 at the end of the year, which was an easy 6% on top of the $5,000. But if we compounded monthly, we ended up with extra money. So it's actually greater than that 6%. So today we're going to figure out how to work out what the actual percentage return on the investment is, okay? And that's what we call effective interest. So in this statement here, which I think is the most important statement of this paragraph, the effective interest rate or actual interest rate represents the actual percentage return per year on an investment. Okay? So that is what we're looking at today. Obviously, if we're considering this as an investment, this is also the same for the cost of a loan. So for example, if I take out a loan at 5% per annum compounding quarterly, obviously I'm going to be paying back more than that 5% because for every month I haven't paid off everything, the interest adds to my debt. Okay? So, it's good if you're saving, bad for a loan. So let's look at how to calculate effective interest rate. This is our formula, okay? We say I effective is equal to 1 plus I on n, all to the power of n, there he is, minus 1. That looks really confusing, so let's talk about it. I effective just means the effective interest rate, that's what we're looking for. I is the nominal rate, or the rate that you're just given, okay? As a decimal, and n is the number of compound periods per year. All right. I will be writing my I effectives as IF like this, just because it's a bit quicker and it still communicates exactly what I'm doing. So let's do an example. We have an let's make sure you can still see the formula. An interest rate is quoted at 3.5% per annum, compounding monthly. What is the effective interest rate? Give your answer to 2 decimal places. All right, let's write the formula. Let's do it, and we're going to sub everything in, and it's going to be amazing. IF, or I effective, equals 1 plus I on n to the n minus 1. Cool. So, substituting in what we know, the interest rate is 0.035 as a decimal. It's compounding monthly, so that's 12 compounding periods per year to the power of 12 minus 1. Okay? That's it. Put it in your calculator. You put it in your calculator, you end up with 0.0356, which as a percentage, so remember as a percentage, we just moved that decimal twice, 3.56%. That's our answer. Our effective interest rate, if we have a compounding monthly, if we have money compounding monthly at 3.5% per annum, it's the same as having an interest rate of 3.56% per year, compounding annually. That's it. So all we're doing is we have to substitute into this formula here, but we can't get confused that I has to be a decimal. Really, really important, okay? Look at him being a decimal. And we just need to make sure that this number here always matches that number there because they're both n's. Let's do the next example, okay? And in the next example, we're going to have to do some comparisons, so bear with it. The interest rate in work example 3 is 3.5% per annum compounding monthly, which is equivalent to an interest rate of this. So we just showed that. We just proved that. The best way to compare interest rates is to determine the effective interest in each case. So here's an example, and these are examples that you are going to encounter in real life when you guys are getting your loans and things like that later on. Okay, so Jack has the choice of investing money in 3 different funds. He's got 3.9% compounding quarterly, 3.95% as simple interest, or 3.85% compounding daily. Which investment will provide him with the greatest return? So what we're going to do for this, guys, is we're going to look for the effective interest rate for 1, 2, and 3. And whichever one gives us the highest effective interest rate will give us the highest return. So let's do it. Let's do question 1 first. So we're going to write the formula. Step 1, I effective equals 1 plus I on n. Okay, for that first example, that's 0.039 compounding quarterly, so divided by 4. Remember those two numbers there will always match. Minus 1. Pop it in our calculator. We end up with 0.03957, which is the same as 3.96%. So I'm just going to round that to 2 decimal places there. So that's number 1. That's this option for Jack. Option 2. Well, the great thing about option 2 is I actually don't really need to do any working out at all, because if we are talking about simple interest per annum, well, it's not compounding, and it is 3.95% anyway. So his effective interest, I always write the F's first, it's so weird, is 3.95%. So we can already see that option 1 is better than option 2, but we need to make sure we check option 3 as well. So let's do that. I'm going to do that over here on the right. I effective, I did it again. Effective equals 1 plus I on n to the n minus 1. Okay, so with this one, we've got 0.0385. It's compounding daily. So the n this time, guys, is going to be 365. We're going to assume there's 365 days in the year. It's not a leap year. To the power of 365 minus 1. All right, pop it all in. We end up with 0.03924. Writing that as a percentage is 3.92% to 2 decimal places. So let's have a look. We've got option 1 is 3.96, option 2 is 3.95%, and option 3 is 3.92%. So we can see clearly here that the best option for him would be option 1. All right, so we're going to make sure we have a statement for this. Option 1 will provide Jack with the greatest return, and we better make sure we state why as well, as it is the option with the highest effective annual interest rate. It is the option awesome. So guys, this subchapter is actually really nice because it's just using that formula. It's going to feel a little bit repetitive, but I'd rather it feel repetitive and you absolutely smash these questions in your final. So here are your questions. You've got exercise 7.3, questions 1 to questions 10. Make sure you email me if you have any questions, and I'll talk to you soon.